Okay, so this is the second part of Unit 5 review worksheet number 1. So I'm going to jump to question number 4 and then solve each of these. So for question number 4, we want to solve for x. So the first thing I always want to do is isolate the square root. So what I'm trying to do is get the square root of x plus 3 by itself. And so anything that is beyond that needs to move to the other side. So I need to get rid of the 1/4 and the -1. And we're going to solve using order of operations backwards. So the first thing I want to do is I want to add 1 to both sides of the equation. And then 1 minus 1 is 0, so I can just cancel that. And 0 plus 1 is 1. And then to get rid of the 1/4, I can divide by 1/4 or I can multiply by the reciprocal. So I'm going to multiply by 4 over 1. And so that gives me 4 divided by 4, which is just 1. And then I'm going to have to multiply this side by 4 over 1 as well. But 4 over 1 is the same as 4, so instead of writing it as a fraction, I'm going to leave it as 4. So 4 divided by 1, or 4. So I'm multiplying both sides of the equation by the reciprocal, so then that cancels, leaving just a 1 behind. But I don't need to write the 1. And then 1 times 4 is 4. So now that the square root is isolated, now I want to get rid of the square root. So I'm going to square both sides. And the square and the root cancel, leaving just the term. And then 4 squared is 16 because 4 times 4 is 16. And then my last step is to isolate the variable. So to get x by itself, I want to subtract 3 from both sides. And 3 minus 3 is 0. And 16 minus 3 is 13. Okay, so for part B, so I can't isolate like the radical because I have 2 of them. So I just want to go ahead and just square both sides. So I'm going to square both sides. And when I square root the squared, that's going to cancel, leaving just a 2x plus 10. And then over here, I'm going to square the root. That cancels, leaving just the 4x. And then I want to isolate the variable because I want to solve for x. So I want to subtract 2x from both sides. And so that cancels. So I have 10 equals 4x minus 2x. And then to get the x by itself here, I'm going to divide both sides by 2. So then x equals 10 divided by 2, which is 5. Okay, and then for part C, a lot like part B. So I can't isolate the radical, so then I just want to square both sides. So here the square root and the square cancel, leaving me with just 2x squared plus 16. And then now this one is different. So I want you to look at here. So when I squared and rooted here, I got just what was remaining, which was 4x. And that's because the 4 and the x were both under the root. But I look over here, and this squared will cancel that root, but this 2 does not have a root to cancel. So because it's not the square root of 2, it won't cancel. It actually has to square it. So I actually have to do 2 squared, which is 4, because there's not a root to cancel that squared. And then over here, it can cancel, so then I'm left with just 3x. So I have to do 2 squared, which is 4, and then this root and square cancel, leaving just 3x. So now I'm going to go ahead and multiply those together. And then because I have a squared, I need to use the 0 product property, so that means it needs to be equal to 0. So in order for it to be equal to 0, I need to subtract 12x from both sides. And then that will give me a 0 here. And then on this side, I just want to put it in the right order. So it'll be 2x squared first, and then minus the 12x, and then plus 16. And then here they all have a 2 in common, so I want to factor the 2 out of everything. So I'm going to do greatest common factor. So when I divide by 2, I'll get x squared, and then minus 6x, and then plus 8. And then when I look at this, I'm going to list my factors for 8 to try to factor. So x squared is x and x, and then for 8, I can use 1 and 8 or 2 and 4. And so the factors that will work for 8 and for 6 are going to be 2 and 4. So I have the 2, and then x minus 2 and x minus 4. So they both have to be negative, right? And so then when I solve, I'll get x equals 2 and x equals 4. Okay. Okay, and then for the last one, so for 4D. So the radical is already isolated, so I don't have to do that. So now I'm ready to just square both sides. So the root and the squared cancel, leaving just x plus 3. And then I have to quantity square that, so I need to write it out twice. And then distribute. So I need to multiply negative x times negative x and to the negative 1. So that'll be a positive x squared and a positive 1x because of the double negative. And then do the same thing for the bottom, so multiply those together, also positive 1x, and then negative 1 times negative 1 is a positive 1. And then I have to combine like terms, so I can add my 1x's together. And then I have to equal it to 0 in order to use a 0 product property and factor. So I'm going to subtract x and 3. So this will cancel, equaling 0. And then 2x minus 1x is 1x, and 1 minus 3 is negative 2. And then from here I want to factor because I have a quadratic, so I have a squared term. So my factors for x squared are x and x, and my factors for 2 are 1 times 2. And in order to get a negative 2 when I'm multiplying and a positive 1 when I'm adding, I need my 1 to be negative. And then solve, so x equals 1 and negative 2. So for this one, I do have to look for the extraneous solution because of turning into the quadratic with the single root. So I'm going to write down my original problem here. So I know that my square root always has to be equal to a positive number, right? My square root cannot be negative. So if I were to let x equal 1, I would have negative 1 minus 1, which would be equal to negative 2. And this square root cannot equal negative 2. So that means x cannot equal 1. So then now, what if I do the same thing again, but now I'm going to do it for negative 2. So I want to do the same thing, but now I'm going to do it for negative 2. So let me wipe this out. So I have the original problem, right? So the square root of x plus 3 equals negative x minus 1. But now I'm going to let x be negative 2. So I already have a negative. So that turns into a double negative, right? Because there was a negative already, and I'm putting in a negative 2. So a negative times a negative is a positive 2, and then 2 minus 1 is 1. And so can a square root equal positive 1? Yes. So then this one is my solution. Okay. All right, and then let's do one more here. We're going to take a look at question number 7, the graphing. Okay, so for this one, in order to graph, I need to be in standard form. So the first thing I want to do is I want to subtract the 4 over to the other side because it's not with the x, otherwise it would be under the root. So I want to subtract 4. So then I want to find my start and stretch. So for my start, I like to see what's affecting the x, so I'm adding 3 to it. So my start would be -3. And then for my y value, I'm subtracting 4, so +4. My stretch, I'm multiplying by -1, so my stretch is -1. And then I want to find my x-intercept and y-intercept. So to find the x and y-intercept, I want to let x equal 0 and y equal to 0. So I'm going to go from here. It doesn't matter which equation I use. I just tend to use the one that's in my vertex form. So I'm going to replace my x with 0. So I have y minus 4 equals negative the square root of 0 plus 3. So then I want to simplify. So I have negative, and then 0 plus 3 is 3. And then I want to add 4 to both sides. And I can't actually add that, right? So it would be negative root 3 plus 4. And I want to be able to graph this accurately, or sort of accurately, and so I need to do that in my calculator, right? So that I can be able to simplify that a little bit. So I'm just going to use my calculator, and I'm going to type in negative square root of 3, and then plus 4. And so that gives me about 2.3. So that is just going to help me graph it, right? All right, and then now I want to do the same thing, but now I want to let y equal 0. So I'm going back to this equation here, but I'm going to replace y with 0. So 0 minus 4 is -4. And then I'm trying to solve a square root, so that means I want to isolate the radicals. So I'm going to divide both sides by -1. So that's a negative divided by a negative is a positive, so I'll have +4 equals the square root of x plus 3. And then now I want to square both sides. So 4 squared is 16, and the root and the square cancel, leaving just x plus 3. And then subtract 3 to both sides. So x equals 13. Okay, so now I'm going to go ahead and graph this. So let me zoom out a little bit so I can get everything in. Okay, so I have a start at -3, 4. A stretch of -1, so down 1 over 1. I have a y-intercept of 2.3, and then an x-intercept of 13. So that's like way out here. It's going to cross, so I'm not going to really be able to show that, so I'm just going to graph to there. Okay. Okay, so now for part B, it's asking for domain and range. So I'm going to go ahead and label and do 4 corners. So the first thing I do is look at my arrows. So for my arrows, this has to take on 2 directions. So it's pointed to the right forever, so that's positive infinity. And the other direction is down, right? So it's pointed right and down, so that means down forever, so negative infinity. And then if I look at the farthest left, it goes is to here, and that's at, let's see, 1, 2, 3, so at -3. And the farthest up it goes is to here as well. So 1, 2, 3, 4. So it looks like 4. So then my domain is going to be left, comma, right. So left, comma, right. And because it's a closed dot, I'm not using parentheses but brackets, and infinities always get parentheses. And then for my range, bottom, comma, top. So negative infinity, comma 4, open and closed. All right, and then the other part it's asking for is where is my function increasing? So for part C, I am increasing nowhere because as I move from left to right, I'm always going down. So let's see, this was the answers to B, right? And answers to A. Let me put my part A, part B. So part C would be none because I'm never increasing. And then for part D, it's asking where am I decreasing on the open interval. So open interval meaning parentheses. And so I'm decreasing everywhere along the domain. So left, comma right. So negative 3 to positive infinity, parentheses for both. Again, because it says open interval. So now for part E and F, it's asking for where is my function positive and negative. And I know I'm positive and negative when I'm either above or below the x-axis. And unfortunately, my graph does not show me touching the x-axis. So I'm going to do a mock-up over here just so I can see that better. So I'm going to do that right in this section here. So I'm just going to kind of generically draw my graph like that. And I know it crossed at 13, right? How do I know that? Because that was my x-intercept, right? So this is kind of a representation of this graph, but showing where it's crossing out here at 13. So it's definitely not to scale, but it gives us the idea that we need. And so I know that my function is negative for part E when I am below the x-axis. So that would be that portion there, right? That's where we are negative. So for part E, my function is negative from 13 to infinity. And it said open interval, so that would be all parentheses. And then for part F, it wants to know where we're positive, and we're positive when we're above the x-axis, so that section. That section right here. And so my start was here at negative 3. So I'm positive between negative 3 and 13. Okay, and that's the end of that.